Deep beneath the towering spine of the Andes Mountains, something ancient is shifting. What was once thought to be dormant is stirring again, and scientists are sounding the alarm. A massive geological force, buried for 500,000 years, is showing unmistakable signs of awakening. The South American supervolcano, a sleeping giant, may be preparing to rise. Recent satellite imagery has revealed swelling ground across a desolate region of the Andes, with seismic activity intensifying in areas long considered stable. Researchers monitoring these volcanic zones are seeing patterns they've only observed before major eruptions. Uplifted land, rising magma, and thermal anomalies point toward a disturbing conclusion: the volcanic threat in South America is growing fast. But this isn't just any volcano. This is a supervolcano awakening, a rare geological phenomenon capable of altering life far beyond the region. This particular colossus hasn't erupted in over 500,000 years, but now the warning signs are stacking up. Earthquake clusters, subtle ground deformation, and spikes in volcanic gas emissions are causing unease in the scientific community. Andes eruptions in the past have left massive scars on the continent. But what's forming now could rival the greatest explosions Earth has ever known. Could we be on the verge of witnessing one of nature's most powerful forces in motion? Scientists just made a shocking discovery, and what they've found beneath the Andes might change the way we understand volcanoes forever. Understanding the supervolcano. To grasp the gravity of this unfolding story, we need to understand what sets a supervolcano apart. While the term volcano may bring to mind fiery peaks like Mount Etna or Kilauea, a supervolcano operates on an entirely different scale. It's not just more powerful, it's a force that rewrites the planet's history. A supervolcano is defined by its capacity for extreme eruptions, those classified with a volcanic explosivity index, or VEI, of 8 or higher. That scale measures how much material a volcano can eject. A VEI 8 eruption isn't merely destructive, it's cataclysmic. To reach that level, a single blast must hurl over 1,000 cubic kilometers of ash, rock, and gas into the atmosphere. That's enough to bury entire countries beneath a choking haze. There have been only a handful of such eruptions in Earth's recent geological past. Around 74,000 years ago, the Toba supervolcano in present-day Indonesia erupted with such force it triggered a volcanic winter, dramatically cooling the planet and possibly pushing humanity to the brink. The Taupo eruption in New Zealand painted skies red across the southern hemisphere. And Yellowstone, nestled in the United States, has erupted 3 times in the last 2 million years, each time leaving behind an enormous caldera and affecting weather patterns across the globe. What all supervolcanoes share is a hidden power. They don't look like typical volcanoes. Instead of rising mountains, they form massive calderas, sunken craters formed after previous eruptions emptied their magma chambers. These vast scars can stretch for dozens of kilometers. Often unnoticed, they lie quietly for tens or even hundreds of thousands of years, until the pressure builds again. When scientists speak of a supervolcano awakening, they're not talking about lava gently trickling down a hillside. They're referring to an event with the power to reshape continents, disrupt the global climate, and rewrite ecosystems. And now, signs of such activity are emerging beneath South America. The Andes supervolcano revealed nestled deep in the Andes, the longest continental mountain range in the world, lies one of the planet's most overlooked supervolcanic structures. In the windswept highlands of northwestern Argentina, near the desolate expanses of Catamarca province, sits the Cerro Galán caldera, a geological giant formed by one of the largest known eruptions in the past several million years. This ancient supervolcano spans an enormous 50 kilometers across. From above, satellite imagery reveals a wide, shallow depression, an unmistakable signature of a collapsed magma chamber. Hidden among the arid plains and jagged peaks, it silently tells the story of a prehistoric explosion that sent columns of ash miles into the sky and blanketed surrounding regions in volcanic debris. Cerro Galán is one of the most prominent caldera volcanoes in South America. Researchers estimate that the eruption which formed it, more than 2 million years ago, expelled over 1,000 cubic kilometers of material, the threshold for a VEI-8 event. That puts it in the same league as Toba and Yellowstone, marking it as a true supervolcano by every geological standard. But Cerro Galán isn't the only one. Across the border in Chile, another candidate stirs, the Pacana caldera, located in the Chilean Altiplano. It's even larger than Cerro Galán and part of the central volcanic zone of the Andes. Formed around 5 million years ago, the Pacana eruption was one of the largest in the planet's history. Its caldera extends nearly 70 kilometers and includes a vast ignimbrite sheet, remnants of pyroclastic flows that once incinerated everything in their path. What makes both of these calderas so vital now is not just their size or history, but the growing body of evidence that suggests renewed volcanic activity beneath them. Satellite data has revealed subtle, yet persistent, ground deformation, the kind typically caused by magma slowly rising from the depths of Earth's mantle. In some areas, the surface has lifted by several centimeters over the past few years. While that may sound small, in geophysical terms, it's a red flag. Further studies using interferometric synthetic aperture radar, a technique that detects minute changes in land elevation, have revealed swelling ground across wide zones around Cerro Galán. When paired with the presence of low-frequency tremors and shallow quakes, the data points to a pressurizing magma chamber. The Andes are part of a subduction zone, where the oceanic Nazca Plate plunges beneath the South American plate. This tectonic collision is the root cause of the region's intense volcanic activity. As the plates grind together, water and sediments get pushed into the mantle, fueling melting rock and feeding enormous magma reservoirs like those beneath Cerro Galán and Pacana. Until recently, these regions received limited scientific attention. But new advancements in satellite surveillance and deep Earth imaging have changed that. Now, with every seismic pulse and every rising plume of volcanic gas, the Andes supervolcanoes are revealing clues, silent signals that hint at movement deep below. And what scientists are finding is both extraordinary and alarming. The possibility of an Andes caldera volcano reawakening after 500,000 years isn't science fiction. It's a real scenario that's rapidly gaining attention from volcanologists around the world. Something is happening beneath the rugged backbone of South America, and it may be only a matter of time before the world feels its impact. Warning signs. Is it waking up? The Andes have always been restless, shaped by millennia of tectonic collisions. But lately, the signs emerging from deep beneath the surface aren't just typical rumblings. Scientists monitoring the Cerro Galán caldera have observed clear indicators that point toward renewed supervolcano activity, and it's becoming increasingly difficult to ignore. Over the past 5 years, a series of seismic swarms has been detected near the caldera. These swarms, consisting of dozens of small earthquakes clustered over short periods, are often associated with the movement of magma. Unlike typical quakes triggered by shifting plates, volcanic swarms usually signal underground fluids forcing their way through rock, building pressure as they rise. In 2021 alone, more than 700 tremors were recorded in a zone where seismic activity was once thought dormant. Most were shallow, centered less than 10 kilometers below the surface, a potential sign of magma migration. But perhaps the most concerning evidence comes not from the quakes themselves, but from the Earth's subtle, silent swelling. GPS monitoring stations set up across the region have recorded uplift readings that reveal the ground is slowly but consistently rising. In some places, the land has elevated by more than 4 centimeters within just 2 years. That kind of vertical motion suggests something is inflating beneath the surface, likely a pressurized magma chamber slowly filling once again. Ground temperature measurements have added another layer to the mystery. Thermal imaging taken via drones and satellite platforms has revealed hot spots near fissures around the caldera rim. These zones are releasing higher than normal heat signatures, indicating elevated geothermal activity just beneath the crust. Accompanying this rise in temperature is the release of volcanic gases, particularly sulfur dioxide and carbon dioxide, known precursors of eruptive behavior. Dr. Carla Ramirez, a volcanologist with the University of Buenos Aires, has been tracking the data closely. In a recent press release, she noted, "We're seeing a combination of uplift, thermal increase, and persistent tremors that collectively point to deep subsurface changes." While this doesn't mean an eruption is imminent, the pattern mirrors those observed in other magma chamber inflation events worldwide. International research teams have also joined the effort, with satellite data from European Space Agency programs confirming the deformation trends. The increasing collaboration underscores how seriously the scientific community is taking this threat. As one expert put it, the Andes may be whispering now, but history shows how quickly that whisper can become a roar. Whether this is merely a geological shift or the early stages of a supervolcano awakening, the evidence is stacking up. And each new tremor, each plume of gas, adds weight to the possibility that this ancient giant may be preparing to rise once more. What could happen if it erupts? The thought of a supervolcano erupting in South America isn't just a dramatic what-if. It's a scenario grounded in science, with historical examples offering a chilling preview of what such an event could unleash. If the Cerro Galán or the Pacana supervolcano were to erupt again, the consequences would be devastating, both locally and globally. At the epicenter, the destruction would be swift and total. Within a radius of several hundred kilometers, cities and towns could be buried beneath pyroclastic flows, dense, fast-moving clouds of superheated gas and volcanic matter capable of flattening entire landscapes in minutes. Ashfall would blanket agricultural lands, poison water supplies, and collapse buildings under its weight. Infrastructure would be obliterated. Roads, power lines, and airports would cease to function, cutting off communities and halting rescue efforts. The sky would darken, not for hours, but for days, or even weeks. The regional devastation would be catastrophic. But the global effects of a supervolcano eruption are what truly elevate the threat to a planetary scale. When a supervolcano erupts, it injects vast amounts of ash and sulfur-rich gases into the stratosphere. These particles can travel along the jet stream, encircling the Earth in a matter of days. As they spread, they reflect sunlight away from the planet's surface, triggering a sharp drop in temperatures, a phenomenon known as volcanic winter. The eruption of Toba 74,000 years ago caused a global temperature decrease of up to 3 degrees Celsius. This seemingly small shift may have lasted for years and dramatically altered rainfall patterns, devastated ecosystems, and reduced the global human population to as few as 10,000 breeding individuals, according to some controversial models. If a South American supervolcano unleashed a similar event today, the impact on food systems could be severe. Crops would fail in multiple hemispheres, triggering food shortages, economic collapse, and widespread social unrest. Air travel would grind to a halt as volcanic ash clogs engines and reduces visibility across continents. Health systems would be overwhelmed as people suffer from respiratory problems caused by fine particulate matter in the atmosphere. The cost of such a disaster is difficult to quantify, but it would certainly run into the trillions. Insurance models don't even account for an eruption of this magnitude, because it sits outside the realm of what most industries consider possible. Estimates vary, but scientists believe a modern eruption of Cerro Galán or Pacana could easily reach or exceed a VEI-8, making it one of the largest volcanic events in human history. The volume of ejected ash could surpass 1,000 cubic kilometers, enough to coat entire regions of South America and affect life across every continent. This isn't just theoretical. The geological record shows that it's happened before. And with magma chambers once again inflating and seismic activity on the rise, the supervolcano disaster scenario is no longer confined to textbooks. It's becoming a conversation among policymakers, geologists, and even climate scientists. As the world watches for earthquakes, floods, and hurricanes, few are looking at the Andes. But perhaps they should be, because what lies beneath could make all other disasters pale in comparison. Scientists divided. Will it really blow? As data pours in from the Andes, one truth becomes clear: scientists don't agree on what it all means. The very experts trained to interpret these seismic signals and volcanic patterns are offering conflicting interpretations, sparking debate in the global geological community. This disagreement isn't just academic. It shapes how governments prepare, how people respond, and how the world perceives the threat of a supervolcano awakening. Some volcanologists believe the current activity at Cerro Galán and Pacana represents normal volcanic behavior. They point out that volcanoes breathe. They swell and contract. They release gases. They tremble with seismic swarms that don't always lead to eruptions. According to this perspective, the Andes supervolcano may simply be adjusting beneath the crust, exhibiting typical geothermal restlessness that doesn't necessarily predict disaster. Others disagree, arguing that the pattern of magma chamber inflation, gas emissions, and persistent seismic activity is escalating beyond the baseline. These scientists warn that dismissing these signals could prove disastrous, pointing to historical failures to predict eruptions. The eruption of Mount Pinatubo in 1991 is often cited, a case where early signs were misread or minimized. Pinatubo had been silent for centuries before suddenly exploding, becoming one of the largest eruptions of the 20th century and cooling global temperatures for years. Only last-minute evacuations saved thousands of lives. The core issue lies in volcano prediction accuracy. Despite advances in technology, volcanology remains an inexact science. Supervolcanoes, in particular, are difficult to model. Their systems are immense, their pressure thresholds poorly understood, and their historical patterns often span hundreds of thousands of years, timelines that far exceed modern observation windows. While tools like satellite interferometry, thermal imaging, and gas monitoring have dramatically improved early detection, they cannot yet answer the ultimate question: when will it erupt? Can supervolcano eruptions be forecast with precision? Not yet. And that's what fuels the ongoing debate. Some scientists are pushing for increased public awareness and preparation, urging governments to take the risk seriously. Others are more cautious, warning against alarmism without definitive evidence. This division reflects the complex nature of Earth's inner workings, where signals are often subtle, overlapping, and open to multiple interpretations. But when a scientist warning of a supervolcano speaks, it's not without reason. The data may not reveal an exact timeline, but history teaches that silence can be deceptive. In the Andes, that silence is being slowly replaced by motion, and the world must decide how closely to listen. Hidden clues in the geological record. Long before satellite imaging and seismographs, the Andes told their story in stone. The Cerro Galán eruption history, buried beneath layers of hardened ash and twisted rock, offers a sobering glimpse into what may lie ahead. Though these supervolcanoes haven't erupted in human memory, the land itself carries the fingerprints of their past fury. Scientists studying the region have unearthed vast volcanic ash layers spread across hundreds of kilometers. These ash beds are not uniform, but occur in distinct layers, each marking a separate eruption, each separated by long intervals of dormancy. Some of these layers are so thick they suggest blast volumes that match or exceed the threshold of a VEI-8 eruption. Radiometric dating places the most recent major activity at Cerro Galán at around 2 million years ago. But smaller, still significant events may have occurred within the last several 100,000 years. The stratigraphy tells a story of cycles, of pressure building, magma rising, then exploding outward in an unstoppable release of energy. Between these cataclysms, the region has seen long periods of silence, sometimes lasting hundreds of millennia. But the geological record suggests that this silence has never been permanent. Perhaps most compelling is the evidence found in ancient ice. Scientists drilling glacial cores in Antarctica and Patagonia have discovered fine ash particles embedded deep within the layers. These microscopic fragments correspond in age and composition to known eruptions from the Andes, adding yet another layer to our understanding of the historical eruption cycles that define these mountains. Each discovery adds to a mounting picture. The supervolcanoes of South America have erupted before, they have followed patterns, and those patterns suggest they will erupt again. The land has already spoken, through ash, through stone, and through time. Now, it may be whispering once more. Could humans survive another supervolcano? If a supervolcano erupted today, survival wouldn't just be about escaping lava, it would be about enduring a global chain reaction. In South America, ash would devastate agriculture, contaminate rivers, and disrupt ecosystems already dependent on fragile watersheds. Millions could lose access to clean water and food. But the disaster wouldn't stop there. Ash clouds would spread globally, grounding aircraft and paralyzing trade. Food supply chains would collapse as harvests failed and shipping lanes closed. Scientists warn of a volcanic winter, where blocked sunlight cools the planet, shortens growing seasons, and triggers worldwide shortages. Some compare it to a nuclear winter, only without the radiation. Technology may offer some defense, but it remains vulnerable to atmospheric disruption. Survival would depend on preparation, coordination, and the ability to adapt rapidly. The real question is no longer whether it will happen, it's whether humanity is truly ready when it does. To stay ahead of the threat, scientists are turning to advanced technology. NASA and the USGS use satellites to monitor land deformation and heat signals in the Andes. Drones scan volcanic zones, while AI helps detect dangerous patterns in seismic activity. This global effort in volcano monitoring technology is expanding fast, but experts say it's still not enough. Regions near Cerro Galán lack public alert systems or evacuation plans. Data is being collected, but without investment in infrastructure, it may not save lives. The Earth is speaking, through uplift, heat, and tremors. It's time we listen. The Andes move slowly, but their message is clear. A future volcanic eruption is inevitable. By supporting geological research and preparing wisely, we can protect what matters most. Because the countdown has already begun, and this is our chance to act.